Good day. This is Module 2 presenting other vector operations, specifically cross product of two vectors and its algebraic properties.
It's 12 hours.
So we have here the definition of cross vector product of two vectors in tree space. It says here, in many applications of vectors in mathematics, physics, and engineering, there is a need to find a vector that is orthogonal to two given vectors. We will discuss a new type of vector multiplication that can be used for this purpose. The cross product, denoted as U cross V of two vectors, U, whose components are U1, U2, U3, and V, whose components are V1, V2, V3, is the vector U cross V equals the product of the magnitudes of your two vectors U and V multiplied by sine theta multiplied by n, representing the normal vector. So as you can see from the figure, we have here two vectors in the plane. So we have vectors U and vector V. And the cross product of these two vectors is the vector represented by the perpendicular vector, which is U cross V. And this is also the normal vector. So as you can see, we have the U cross V or cross product perpendicular to the two given vectors, vector U and vector V. So we have here the two vectors again. This is now in two-dimensional space. So we can now define that the cross product can be used to find area of a parallelogram. But we will have the discussion of this detailed in the next part of the video. So if we have now to calculate the cross product as determinant, so we have here the corresponding formula of cross product of two vectors, having now a 3 by 3 determinant, where the first row is the ijk vector, then the second row are the components of your vector u, which are u1, u2, u3, and vector v, we have it, the components of vector v in the third row. So this makes us a 3 by 3 matrix. And we know that in finding determinant of a 3 by 3 matrix, we can use the methods that we have learned in linear algebra, and that is cofactor expansion about a row or a column. So in here, we're going to select the first row as our cofactor and finding its determinant. So we have this now as, we have the following formula, which is now the first determinant or subdeterminant or submatrix rather, we have u2, u3, then b2, v3 times I minus u1, u3, then we have v1, v3 times j, then we have u1, u2, v1, v2 times k. So this, we have the result of obtaining the determinant of the product, cross product specifically, of the two vectors using cofactor expansion. Or equivalently, we may now have this as the corresponding formula to simplify the result of this cofactor expansion. So where we have it as u cross v equals u2 v3 minus u3 v2 times I minus u1 v3 minus u3 v1 times j plus u1 v2 minus u2 v1 times k. So do not memorize these formulas because you can obtain this while you are using the cofactor expansion for the determinant of the cross product. For the algebraic properties of the cross product, it says here, let U, V, and W be vectors in space, and let C be a scalar. So for the first property, we have U cross V equals negative of V cross U. So in other words, cross product are not commutative because the result of the cross product of the two vectors in this manner, U cross V, will have a different sign when you obtain the cross product of V cross U. It will be negative. The other will be positive. For the second property, where we have this as distributive property, so we have here U cross quantity V plus W equals, you can have it as U cross V plus U cross W. So that is distributing your vector U to the sum of these two vectors V and W. For the third property, which is involving a scalar multiplied by a cross product of two vectors, so that is C times U cross V equals CU cross V rather equals U cross CV. For the fourth property, if we have vector U cross 0 vector, it is also equal to 0 cross vector U equals 0 vector. Then for the fifth property, U cross U equals 0. And then we have the sixth property, which is U dot quantity V cross W equals U cross V dot W. Let us work on this example. So it says here, find A cross B, meaning the cross product of two vectors A and B, given vector A equals I minus j plus 3k, and vector B equals negative 2I plus 3j plus k. So let's identify the components of your vectors A and B. So we have it as vector A will have in component form or bracket rotation form, that's 1, negative 1, 3. And then your vector B, we have it as negative 2, 3, 1. So getting now the cross product of these two vectors, so using the formula, so first row is ijk, the second row is, we have 1, negative 1, 3. Then we have negative 2, 3, 1. By the way, there's another alternative that you can use if you're not familiar with cofactor expansion, and that is using the basket method. And what is this basket method? So we just copy the first two rows, or rather two columns, and place it here. But I'll show it to you later. So let's first use the cofactor expansion. Okay, so with that, we now have A cross B equals, let's get the factor I. Then let's identify the submatrix form. So delete the row containing I. We have the submatrix form, which is negative 1, 3, 3, 1. Then you have J, but the sign is minus because it's alternate positive, negative, positive. Okay, so it's minus J. Then define the submatrix form by deleting the row containing J and column. So the submatrix form, we have it as 1, 3, negative 2, 1. Then we have plus K. So we have the submatrix form by deleting now the row containing K and column. So 1, negative 1, negative 2, 3. 1, negative 1, negative 2, 3. So let's now have A cross B now. So we have I, then applying the 2 by 2 determinant. So negative 1 times 1 is negative 1. minus 3 times 3 is 9. Then you have minus j, then applying determinant of 2 by 2. So starting from the upper left corner, 1 times 1, diagonal multiplication, that's 1 minus 3 times negative 2 is negative, 6 times negative, that's positive 6. Then we have plus k, and this is positive 3 minus multiplying negative 1 times negative, that's positive 2. So that is 3 minus 2. And the result of A cross B using cofactor expansion, we have it as negative 10i minus 7j plus k. Or we can also write this in component form, negative 10, negative 7, 1. So this is how we solve the cross product of two vectors using determinant, specifically cofactor expansion.